Am I audible?
Yes, Tanveer, it's audible.
Okay. So do you have any questions from previous session? No queries? Okay. So today we have planned for IP addressing. So we will start IP address first. My screen is visible to all of you.
Yes, sir.
Okay. So let's start first. Okay. So first of all, we will start with this MAC address. What exactly is the MAC address? So every device will have the network interface card either for the LAN connectivity, the wired connection, or for the Wi-Fi. And for this, there is a hardware-based chip. So that chip will be either on the motherboard or we are going to plug any external NIC for wireless connectivity or for wired connectivity. Okay. So in every network interface card, whether it is a wired or wireless, there will be MAC address. So this MAC address is integrated in the chip. So when the chip is developed on that time, manufacturer is going to define the MAC address, and that MAC address is always defined in hexadecimal format. Okay. So when we talk about the number system, there are four types of number system available. One is called decimal, which we are using in day to day. That is also known as base 10, and decimal number system will be from 0 to 9. Next we have hexadecimal. Hexadecimal number system is referred as base 16, and this base 16 means it will be 0 to 9 or A to F. Sorry. So in hexadecimal number you will see it will go for 0 to 9, and after 9 for the 10 it will be A, for 11 it will be B, for 12 it will be C, and so on. Another type of number system we have, that is binary. For binary, it is referred as base 2. It will be either 0 or 1. One more number system we have, that is octal. Octal number system is referred as base 8, and it will be from 0 to 7. So these are the number system. In this IP version 4, we are going to talk about decimal number system and binary number system. Okay, so octal is used in the programming, and hexadecimal number system is used here in our lot of places, but in this network which we are going to cover in this part, we will see hexadecimal number system in MAC address and in IP version 6. Okay, so now this MAC address which we are talking about, that is here in hexadecimal format. Okay. So when we talk about the length, okay, what does this length mean? Okay. So when we talk about the length, what does it mean? If I ask you what is the length of your mobile number, you will say it is of 10 digit. I will ask you what is the length of your name. So you are not going to measure with any tape, or you are not going to measure with a scale. So you will measure your name in terms of the letters. So my name is of 5 letters, my name is of 6 letter. Similarly, when we are going to talk about the mobile number or any other thing, we measure in what it is written or in what it is represented. So similarly, when we talk about the MAC address, it is represented in hexadecimal, but when we talk about overall length, so in computer system, everything is in binary. So either it will be 0 or it will be 1. So when the MAC address is converted into binary, then this binary numbers, how many binary numbers is used to represent that MAC address, that is called the length of that MAC address. Okay. So let us see the data units. So what are the data units we have? One binary digit in computer system, you know very well that we have binary. We use binary either 0 or 1. So one binary digit equal to 1 bit. Similarly, 4 bit equal to 1 nibble, and 8 bit equal to 1 byte. Then 1024 byte equal to 1 kilobyte, and this bit is represented in small b, and when we talk about byte, it is represented with capital B. Similarly, this kilobyte will be represented as KB, and then so on. 1024 equal to 1 megabyte, that will be represented as MB. 1024 MB equal to 1 gigabyte GB, and similarly 1024 GB equal to 1 terabyte is the TB. Okay, so this is how the data unit is defined. So when we talk about here, 48 bit means 48 binary digit is used in this MAC address. Okay, till here things are clear. Do you have any question?
No, sir, it's clear.
Okay. Now coming back to the MAC address. So this first thing is, it is integrated in NIC card of the device, means it is integrated in the chip. So we cannot change the MAC address. So in general, if you have heard about that, the MAC address is modified, MAC address is changed, and then attacker is going to attack. MAC address is changed, but not of the NIC. MAC address is changed when the packet is constructed to send towards the destination. Before that, these all things are being changed. Okay, so that is the MAC address. Now, this MAC address is defined in the chip using the embedded system, so it cannot be changed, and that is defined by the manufacturer. First 24 bit of the MAC address is manufacturer ID. Means if you see here, it is 12 hexadigit, and every one hexadigit is equal to 4 binary. So half of the MAC address always refers to the manufacturer ID. So if we have two network interface card from the same manufacturer, then half of the MAC address will be same. Okay, and the remaining is the device ID. Okay, so it will change randomly. Now we cannot change the MAC address, and MAC address is referred with 3-4 names. What are the names used to refer this MAC address? One is called hardware address. Why hardware address? Because it is integrated in the hardware. Okay. Next. Next we have physical address. So it is represented as a physical address. Then one more thing is there, that is L2 address, layer 2 address. Because this MAC address is used on layer 2 of OSI model. So we say as a layer 2 address. We also say it as a MAC address. Okay. So these are the names using which we refer this MAC address. So what we can do with the MAC address? We cannot change the MAC address. Then we can check the MAC address of any interface. So we have two options. One is the graphical, one is the command line. So when we talk about the Linux, in that case, let us see. Okay, so here we'll go on the terminal. On this terminal, we'll type the command ifconfig. Okay. When you type ifconfig, you can see the MAC address. You see, it is also known as Ethernet address. You see, Ether. So this is the MAC address of the interface, and the interface name here is ENP0S3. Okay. Also, we have command IP address. Through that also we can check the same. So here we can see link/ether, so Ethernet address. Same if you want to check in the Windows, we have ipconfig /all. So when we use this command, like you see for Wi-Fi, this is the MAC address represented here as a physical address. Similarly, if you want to see for another, you see VMware net adapter, for its MAC address is different. For every interface, the MAC address will be different. Here you see Ethernet adapter, where I have not plugged the cable. For that also we have the MAC address. Another command we can use, that is get MAC. With this also we can get the MAC address, but here it is very tough to identify which MAC address belongs to which interface. If you want to see graphically, use the command ncpa.cpl or open the network connection panel. Here just right click on any icon and click on status detail. So you can see this is the physical address. Okay. So this is the Wi-Fi physical address. Similarly for the Ethernet, if you want to see, you can see here. Okay. For VMware adapter and so on. So this was the MAC address. Now moving to the next, that is the port address. So what exactly is the port address? So port address we need to see when we are going to cover the topic firewall. In the firewall, we have to allow either protocol or the port number. So what exactly is the port number? So as you know very well about the protocol. So protocol is the set of rule how the communication will take place, that is defined in protocol. So a lot of protocols are developed and being developed also. So whenever any protocol is developed in this world, that needs to be registered first. Without registration, it will not get the identity. While registration of this protocol, one number is assigned to every protocol, and that number ranges from 0 to 65,535. I have mentioned here 1 because 0 is reserved. And this is the range. From this only the port number is assigned. And who is the assigning authority? So assigning authority is INA, Internet Assigned Number Authority. Okay. And what exactly is the INA? So INA is an organization which is in California, US, and the task of this INA, you see, the global coordination of DNS route, IP address, and Internet Protocol resource. Okay, so these are the three main tasks performed by the INA. Domain name registration. Whenever we want to have our own website, anything, we give the domain name. So we need to register the domain. Okay, so that domain name registration to make it unique is centrally maintained in the world by INA. So it is having a lot of organization under it which is going to provide the service, but overall the database is uh, maintained centrally. So this control is also with the INA. So root zone management, database of top level domains, and these all things. Number resource means what we are going to learn now, IP address. That IP address is also defined, developed, and designed by INA. So which IP address will be private, which public, which we can use, which we cannot use. These all things are defined. Then coming to the protocol assignment. So any protocol which is developed, protocol registries apply for an assignment, and the time zone database. There is a lot of time zone, different time zone for every country, and in some countries there are 3 4 time zones also in the same country. So this time zone database is also maintained and handled by the INA. Now this INA is having RIR. Like we have in our India, we have the central government, but central government cannot control the entire India. So we have a structure state wise. Then again, a state have its own government, and again, a state government cannot manage. Then there is a district level of management which is done by the district magistrate. So similarly, here we have INA. Under the INA, we have RIR. So this entire world is divided into three RIR earlier: APNIC, ARIN, RIPE NCC. So earlier it was until 2002. After that, it changed 2002 to 2005. It is divided into four RIRs. Then now it is divided into five RIRs. Okay. So this complete Africa comes under Afrinic. Russia, Europe, and Middle East, it comes under RIPE NCC. Our India and the neighboring countries, along with this China, Japan, and Southeast Asia, all this Thailand, Indonesia, this Australia, New Zealand, this all comes under APNIC, Asia Pacific Network Information Center. Then South America is separate as a LACNIC, and North America as an ARIN. Okay. So we are in this APNIC. Again, this APNIC cannot be handled by one location. So this APNIC head office is in Australia, and it provides the service either online or with the help of ISP. Okay. So these are the things is performed by the APNIC. So now if we need any IP address solution, we are under the APNIC RIR and we get it through Internet Service Provider, ISP. So this is the complete hierarchy and structure, how things are managed and maintained in this entire network. Now the next we have, that is list of TCP and UDP port numbers. So when you search for it, you'll find the list, and in this list you can see we have full details. Like you see port number 1 is assigned to which protocol, 2 is assigned to which protocol. Similarly, if you see for the well known like FTP, port number 20 for data transfer, port number 21 for uh, authentication, port number 22 for SSH, 23 for telnet, SMTP 25, and so on we have, you see. And this port number is not assigned in a series, not in a sequence. It is assigned randomly. So you will see there will be a gap. So this decision is also taken by INA. Okay. So any question till here?
Tanveer, what is mean by yes and assigned in that
Huh?
port number? In the port numbers, what is mean by yes and assigned?
Just a minute. You want to ask this, na?
Yes.
Okay. So protocol is assigned by INA for this port, and unofficial means not assigned by INA for this port, but standardized and it is widely used for this port protocol. Okay. So same thing here you can see assigned by INA. Okay. Unofficial, yes means assigned by INA. I hope now it's clear. So here is the tag and its mean. No described protocol is not assigned by INA for this and widely used for such. But it is standardized. It is assigned means protocol is assigned by INA for this port, but not standardized. So there is two things: standardized, not standardized. Okay. Is this clear?
Yeah, Tanveer, it's clear.
Okay. So now this port number is assigned by INA, and when we talk about the length, it is represented in decimal number system, like how we talk in general 1000, 2000, 3000, like that. So like this, it is represented in decimal number system. Now the next is IP address. So in this MAC address, we cannot do anything. We can just check protocol port number. This port address also we cannot do anything. It is predefined. So we can just check which port number is assigned to whom. Okay. Now coming to the IP address. Okay. IP address is what? IP address is a logical address. Why we say it's a logical address? Because now this is defined for this specific device. Later there will be a different IP address. So we can change it. Okay, we can assign the same IP. We can remove from this device. We can configure the same IP on another device. So it's our own logic. And we are configuring IP address for what? To identify a host. Host means all the device on which we can configure the IP. That is referred as a host. Okay. To identify a host or node or any device in the network, we use this IP address. There are two versions of IP address, IP version 4 and IP version 6. So IP version 4 is of 32-bit in length. So again, the same case. 32-bit in length means when we convert into binary, and it is represented in decimal number system. IP version 6 is of 128-bit in length, and it is represented in hexadecimal number system. Okay. Okay, just 2 minutes. I'll be back. Okay. So IP version 4 is of 32-bit in length and represented in decimal number system. So as we know, if it is of 32-bit in binary, and let us convert it. So convert binary to decimal, decimal to binary to decimal. So let us see. 1, 2, 3, 4, 5, 6, 7, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So these are 32 binary digits. So when we are going to convert it, this will be the number. So suppose if we had this IP address and second IP address is like this. So which one is easier? This one. So I think this one, if the IP address they have designed in this way, like without any division of IP address in blocks, then we would have these values and we can pronounce this one easier, right? So which format of IP address, this one or this one? Which one is easier to pronounce and memorize?
The second ones are separated by dot.
Or this one? This one also we can pronounce, na? So how much is this? Can anyone pronounce it?
That's difficult, sir.
So that is the reason I just wanted to explain the concept. So that is the reason IP version 4 is divided into blocks, 4 blocks to make this address readable. Okay. So if they would have not divided into blocks, then we would have this type of address, IP address. Okay. So this is the reason. So when 32-bit is divided into 4 blocks, so every blocks will be 8 bits and it is separated with the dot. Okay. So because of this, every block is known as octet because every block contains 8 bit. Now, IP version 4 is divided into class as per the network size requirement. Okay. So the network can be larger, the network can be medium, the network can be small, and there can be a network where we don't have any host. There is only network like that. That is called multicasting. So class A, in the class A, first block will be used for network addressing and 3 blocks remaining will be used for host addressing. When host addresses are more, host bits are more, we can generate more host address. So in a single network, when we have more host address, it makes large network. So in class A, single network, there will be 1 crore 67 lakh 77,216 IP address. Similarly, class B, 2 network, 2 host, means 2 block is reserved for network addressing and 2 blocks are reserved for host addressing. And in one network of class B, there will be 65,536 IP address. So that is our medium network. Similarly, for class C, 3 block is reserved for network addressing and 1 for host addressing. And it has in a single network of class C, there is a 256 IP address. Okay. And class D is reserved for multicasting. So any type of group call, video uh, conferencing, audio conferencing, group messages. So for this purpose, this class D address is used. Class E address is reserved. For which purpose it is reserved, it's not revealed. So if someone says that class E IP address is used by our army or in the defense system. So it's not the fact. Okay. So I have gone through those networks and I have seen they are using the private IP address of class A, class B, and so on. Okay. So any question till here? Okay. So now moving to the next, that is first block. If you see in this class A, B, C, D, first block is used for network addressing. Okay. So that's why to identify class of any IP address, we use the first block, because when it is used for network addressing, it will not change system to system. If there is a network of 1,000 computers, then for entire 1,000 IP address, the network ID will remain same. If 1,000 computers are in the single network, okay, so network part will always remain same in a same network. Now, as the class of any IP address is identified with the first block, then we have to define the range. So in binary, minimum it will start from 000, and maximum we have to put all 1. So if we put all 1, it will finish here only. And we cannot divide like 256 divided by 5. So total, why I have written 255? Because when you convert this binary into decimal, so it will start from 0 and it will end up on all bit 8. So the value will be 0 to 255. So what Aina has said for this division, the rule, that is for class A, first bit must be 0. So you can see first bit is 0 in minimum also and maximum also. Rest all is 1. So when we convert into binary, it becomes 0 to 127. Similarly, class B second bit must be 0, class C third bit must be 0, class D fourth bit must be 0, and class E, as it is the last class, so all bit will be 1 here. Okay. So when we convert these all values in a decimal number system, then it will come 0 to 127, class A, class B 128 to 191, class C 192 to 223, and class D 224 to 239, class E 240 to 255. So this is the range. So what you have to do, you have to memorize this range. Okay. If you want to learn IP address properly, then you have to memorize two things: in which class how many blocks are network and how many are host. So as you know, there are only 4 blocks. So it is very easier to memorize. Like A, you assume it is 1, B 2, C 3. So A 1 means in class A 1 block network. So remaining 3 will be host. Class B, B means 2, 2 means 2 blocks are network, and remaining 2 is host. Class C comes on third position, so 3 blocks network, and 1 it will remain, so it will be host. Class D, it comes on the fourth position, so all 4 will be network. Now when we talk about the binary here, so it will be 128, 64, 32, 16, 8, 4, 2, 1. So how it is like this? It is calculated like this: 2 to the power 0, 2 to the power 1, 2, and so on. It will move further. So right to left, we calculate. So the bit which is 1, we are going to add the values. And the bit which is 0, we are not going to add those values. Okay. So that's why in IP address, it will be from 0 to 255 only. It will never be more than 255. You can convert accordingly and you can calculate. Okay. So now here, I'll take a small test. Tell me, this IP address belongs to which class?
Class B.
Class
So
B.
class B, sir.
Why? Here 100 is also not there.
It's in the worst part is there now. It's in between from 127 to 192. Sorry for the network part initially.
The first bit we have to check it, sir, whether it is belongs to which class, and remaining bits we do not have to take into the consideration.
Correct. So only the first block values we are going to check, and the remaining we don't need to check. Okay. Now the next. So both the IP address are in the same network or different network.
In the different network.
Same,
Different networks, sir.
same,
Same network, correct?
same.
So why it is in the same network? Because both are in class B, correct?
Yes.
In class B, how many blocks are used for network addressing?
Two,
Two, sir.
2. So the same I told you now that 2 blocks are network. So the value of 2 block, if it is same, then only we will say they are in the same network.
Okay.
Understood? So always to identify any IP address, if there is a 2 IP address, then if it is a single, then directly you can see and say that okay, this IP address belongs to which class. And in every IP address, you have to see first the class and then according to class, how many blocks are network.
Okay.
Always to be in the same network for 2 devices, this network block value should be same. If it is different, means they are in the different network.
Okay. Okay.
Okay. Yeah. Now, tell me, both the IP address are in the same network or different network?
Same network, sir.
Same network. Very good. Anyone else? Rest all, what do you think? Same or different?
Same.
So only till now I have heard voice of 2 people. What about others? Hmm? See, it is not in the same network. First you see, it belongs to which class? Hmm? B,
Class C.
class C. How many network are there in class C?
3.
Hmm? 3. So now you tell me, same network, different network?
Different network.
Different network. Is it clear? So
Yes.
always, whenever we see any IP address, keep in mind, first we will see it belongs to which class, and then immediately we'll find out how many blocks are network, and the network value should be same. Okay. So this much values and everything we have to memorize. Now moving to the next, that is types of IP address. So there are four types of IP address. One is loopback IP address. So loopback IP address means what? Loopback IP address used for self-testing and troubleshooting. Okay. So there is a range 127.0.0.0 to 127.255.255. So what? How we will identify any IP address is loopback or which? So if any IP address starts with 127, means it is a loopback IP address. Okay. And loopback IP address is used for self-testing and troubleshooting. We cannot configure on our devices. Next type of IP address is link local or APIPA, automatic private IP address. So APIPA IP address is used when our device is set to obtain IP automatically from the DHCP server and DHCP server is not available in the network. Then it is a feature of TCP/IP protocol that it will take one IP address from this range as a temporary IP to stay in the network. And this IP address also we cannot configure anywhere. Third one is private IP address. So private IP address is used in LAN. So always keep in mind 127, if you see any IP address starts with 127, you will directly see after that whatever value is there. We don't need to bother. We'll say directly it is a loopback IP address. If any IP address starts with 169.254, not only 169, 169.254, then we will say it is a link local or a PIP IP address. Now, the next is private IP address. So private IP address is used in LAN. Okay. So private IP address is used in LAN, and for every class, INA has given private IP address. And private IP address is free to use. Anyone can use. That's why you will see everywhere they are using 192, 168 like this. So if you want to create a large private network, you will use class A private network IP. If you want to use for class B, class B, class C, class C. And this IP address is free of cost, but using this IP, you cannot access internet. Okay. So if you are trying to access internet, then you have to use public IP. Now you may say that no, like just for example, that here you see I have internet connection, but the IP address is private. There is a one technology called NAT, network address translation. So that is generally done on the router. So our private IP gets translated in public IP. Okay, so you have seen just now it is 192.168, but when you type the command, what is my IP address? Okay, so here you can see so it is trying to detect, and once it detect, you will see it will show us the ISP and all the details. Okay, and that will be our public IP. Okay, so let it detect. What is public IP? So public IP is used to communicate in internet. So if you need internet connection, definitely you will have the public IP. And this public IP is assigned. Which IP I can use? It is not up our choice. Our choice is only till here in the private IP. This from this range, any IP we can use. But public IP, we have to take from ISP, and for that we have to pay, that is based on subscription. And if we have public IP, then we can access internet. So which IP addresses are public IP? So whatever range we have defined in 1, 2, and 3. So except this all, rest all IP addresses are public IP address. Okay. So still it is detecting. I think I'll go to other site. What is my IP address? You see. It is not 192.168. This is showing the IP address of my laptop. Okay. So this is about the public IP address. Now the next is, if you find any IP address as 0.0.0 that is used as a default network ID, and we don't configure this IP, so it is referred as an invalid IP. So default network ID, like we cannot give name to our kids as a human, because human is what? It refers to all, whether it is a kid, woman, men, anyone, and it is a Indian or it is a Chinese. So everyone is referred as a human. So similarly, if we want to refer any network, any of any class, any IP address, we use 0.0.0 as a network ID. When we want to send IP message to all as a broadcast IP, broadcast message, we use this IP address as a destination IP. So this IP address we cannot configure on our device. So this is what default network ID, this is what default broadcast ID. And when we are using this IP address, the valid IP address, in that, in other numbers, if the host part is 0, okay, if host bits are 0, that is also represents network ID. So that also we cannot configure. And the broadcast ID means any IP address starting with this value, we want to send message to all, then we use this all host bit 1, which becomes 255 in this class C. So that is represented as a broadcast ID for that network. Now, when we configure IP address along with the IP, we need to configure subnet mask. Because what happened when we do the subnetting, then the order of the bits, network bits and host bits are changed. So that's why, to make this computer system understand how many bits are network and how many bits are host in a network, we define subnet mask. So subnet mask is a numerical value represent number of network bit and host bits in an IP address. 1 is used to represent network bit and 0 for host bit. Okay. So this is the IP address, suppose, of class C. So as we know that class C have 3 blocks of network. So 3 blocks we have put 111 and 1 block for host. So we have put 000. So when we convert it into decimal, we get 255, 255, 255, and it is the subnet mask. Similarly, for class B, we can write directly just to make understand we have converted here. Class B 2 block network, so 255, 255, and 2 block host, so we have written 00. So this is what? Subnet mask. Next we have CIDR. So CIDR is what? Shortest form of representation. Just to represent how many bits are network in this IP, we use /24. Slash and then number of network bits. So it is of class C. So 888, it becomes 24. So here the 24 is CIDR. Then based on the bits arrangement, there are two types of IP address. One is classful, one is classless. So the IP address for which bits are arranged as per the class, that is called classful IP address, and the bits which is not arranged as per the class, that is called classless IP address. Like here you can see, it belongs to class C, 24-bit network, class B, 16-bit network, class A, 8-bit network. Similarly here for the classless, we can see example. It belongs to class A, it should be 24, but here it is 27. Similarly, class B, it should be 16, it is 24. Class A, it should be 8 bit, but here it is 24. Okay. So this much we have in IP address. Do you have any question? Is it clear? So in this IP address, you have to memorize some of the things like the range, okay, of every type of IP address plus the range of every class and how many bits are network and host.
It's clear, sir.
Okay. So next class, we are going to see the networking configuration of our Linux. Okay. So you revise this all, and if you have any queries, then we will discuss in the next class.
Sure, sir.
Okay.